All right, so in today's lesson, section 811, we're doing the washer method. We've been working for the past couple days finding the volume of a solid revolved around an axis, whether it was the X or Y or some other horizontal or vertical line. And so today, we're going to be doing the washer method, which, again, the process is almost the same, but we just got to change how the formula is set up is the main part here. So we have our a problem here we've been working on for several sections now with the square root of x and x squared. And we're looking at our region right here. And now we want to revolve it around the x-axis, that whole region, not just one line around, because usually we're dealing with just one equation, maybe the square root of x. And so we were creating some almost like a funnel, filled in funnel shape or something. So now what happens is when I look at drawing the reflection axe, when we look at rotating it, we have this piece right here, we have that piece right here, and there's the filled in section that we see, that we've been seeing. The challenge is we have this gap. We have this gap right here in the middle. There's this gap in the middle. All that is open. So to me, it's almost like this is the way that they pick these two equations. It's almost like if you look at the inside of a tulip, and there was nothing inside but just the outside of the petals is all that was there. That's what I imagine this kind of looks like. It's more or less a cup, or what that is. I know it's kind of comes to a point at the end, but it's kind of like looking at the inside of a cup that's got a nice round, goes out on the edges and not straight up. So they asked us to find the volume of it, so let's go ahead and start the process. Again, we're going to start off with our integral of from 0 to 1. We got our pi in there. And then now there's a couple different ways, and I'll show you a couple different ways that you can do this. I'm going to show you a shorter, or a longer way, but then a shorter way. And again, you get your pick on what you want to do when you do it. So first thing we want to think about is doing the outer part. We want to take it, like what we've been doing. We've been taking the outer edge and finding the volume of the whole thing being solid. And so that's what we're going to do first. So we're going to take that outer part, which would be basically the square root of x squared dx. And then that's the outer edge, and that would, if we left it alone like that, then that's what we've been doing for the past couple days. But we need to now subtract off the green stuff on the inside of my picture here. So we need to subtract off that inner part. So we're going to subtract off the integral from 0 to 1 of pi times the inner equation, which would be x squared dx. And then that's fine. That is a perfect answer for it. We can simplify from there as we go forward. We can, we want to be careful trying to combine it into something, but we could technically simplify and combine. We can go through and say, all right, this is the integral from 0 to 1. I'm going to stick the pi out front of square root of x squared is just x dx. And then we have minus pi, the integral from 0 to 1. And then we'd have x to the 4th dx. And then now this is where we got to be careful on how we simplify. But really what happens is the pi comes out front, and then the integral. And then now it's really the x minus x to the 4th is what comes next. X minus x to the 4th, and then dx. And that's what it simplifies to. Okay, so again, this is a fine way to go about doing it. I will show you an alternate approach that we can do as well here in a moment. So again, generic formula here that I just showed you, pi times, and I'm going to let the capital R of x stand for the outer radius, and then a little r of x stands for the inner radius. Now you can use your f of x and g of x here too if you want to. It doesn't matter. You just got to know which one's outer, which one's inner is all you got to make sure you do. So it doesn't really matter. I would just let since we always talked about f of x being the top equation and g of x being the bottom equation, I would stick with that kind of format here of doing, sorry, I didn't mean to have it. That'd be a negative x. Didn't want to throw you off there. I would just have outer be the f of x and the inner be the g of x, if you're going to use the f of x and g of x notation. So again, generic formula here is we have the outer radius squared dx minus from a to b pi times the inner radius squared dx. And again, we can do one nice, concise one where, again, the pi comes out front, and we can just say, all right, it's just the r of x equation squared minus the little r of x equation squared dx, where r of x is the outside of the object, and little r of x is the inside radius of the inside. And the key thing that here, when you're thinking about the difference between what we did the past couple days, we had the quantity of, after the subtraction, there was subtraction going on, and then that quantity of that subtraction was being squared. Here, each individual radius is being squared, and that's the big difference here. Is there's a difference between the two setups there, and that's where we're going to have to be careful showing all the steps, that we don't confuse what we've been doing with the disk method with what we're doing with the washer method. So here's an example we get to run through, and it says find the volume of the region enclosed by y is equal to x squared plus 1, y is equal to 2x plus 1, and rotated about the y-axis. All right, fantastic. So I'm rotating about the y-axis. So that's reminding me that I need y as the variable. I need to get these equations in terms of x is equal to when I get all set up. So now, real quickly, as I sketch, well, what would that look like as I rotate around it? Well, they showed us the parabola, so now all we got to do is, whoops, that was too crazy of a thing. I need to go from here to here. And again, we're taking this part right here, and we're revolving it around this way. So, is what I end up seeing, okay? So, again, let's get our equations in terms of x is what we need to do. So, as I'm going to use this dead space up at the top here, well, we got plenty of space. So here I'm going to say y minus 1 equals 2x, and then we have y minus 1 over 2 equals x. And again, if you'd rather have that as 1/2 y minus 1/2, you're fine. That's whatever you want to do. I'm going to use the one on the right-hand side here. Next one here, I bring the 1 over, so y minus 1 equals x squared. Take the square root of both sides. I got plus or minus square root of y minus 1. Now, as we look at it, well, do we need both? Well, technically, the both positive and negative are involved in the process, but we're really just only have to worry about the positive one, because the positive one is this side right here. So we really only need the positive in the process of what we're doing. So we'll go ahead and take around away the plus and minus, but always keep in mind the plus and minus. So now I'm going to write it again both ways is what I'm going to write it, just to have it down there. So doing it in two integrals. We're going from 0 to where they touch up here, which looks at 5. Again, we can solve for what that is. We can solve to see when do those two things meet? When does x squared plus 1 equals 2x plus 1? That would give us the x value, and then we can find the corresponding y value. So if I solve real quickly, we get x squared minus 2x equals 0. So x minus 2 times x equals 0. So that means be at x is equal to positive 2, which looks right. And when I put a positive 2 in there, 2 squared plus 1 equals 5. So from 0 to 5. And then we have our pi. The outer, so which one is on the right? Well, the one on the right would be technically the square root of y minus 1 graph. It was the part of the parabola, so it would be the square root of y minus 1 quantity squared dy minus now the inner radius from 0 to 5 of pi times, which was the diagonal line, so that would be the y minus 1 quantity squared, or divided by 2 squared dy. So there's one way we can see the answer. The other way is we just see one integral, 0 to 5, maybe stick the pi out front, and it's the first term squared, so square root of 1 minus y squared minus the square root of, got ahead of myself now, minus y minus 1 quantity squared dy. All right, so again, most of the rest of the problems are going to have you go through and actually solve it all the way out for the numerical answer. But again, we've been working with these. Go make sure you practice simplifying and doing what you need to do. Take the antiderivative by hands on some of the easier problems, as opposed to just going to straight to Math 9 and the calculator to always get it. So that way we're good for our test next week on what we're doing. Again, on Monday, we'll pick this back up and we'll just do the same topic. The only difference is we're going to be revolving around some other axis besides the x-axis or the y-axis. So some other horizontal or vertical line, like we did in yesterday's lesson.